Hey, I came out here to talk to you a little bit about quantum physics and show you a little bit about, read to you a little bit about one of these books I've been reading here, just to explain things to you a little bit. So I'm out here this morning doing a little bit of yard work. So it's pretty early. It's 7:30. It's 7:30 a.m. and it's already 82 degrees Fahrenheit, and that was 28 degrees Celsius. I was just looking at the thermometer here on the house. So it's 7:30 in the morning and it's 82 degrees Fahrenheit already and 28 degrees Celsius, what it shows on the thermometer. Alright, so what I wanted to do here is talk about quantum physics a little bit, and there's a couple books here. The Quantum Bigfoot by Morehead. He spent 2 years researching to write this book, and this has a lot in it about quantum physics and how it has to do with explaining some of the things that we're finding with Bigfoot related. So there's also some other books too you can get. These are Quantum Physics for Beginners, as well as this one is like a Quantum Physics for Beginners too. This is called Into the Light. So I just wanted to read a few things. So this is for beginners here. So I want to read a few things here out of this book, just to kind of give you an idea of what I've been researching. But let me explain one thing too. Let's see, this is some of the equations. You don't have to be a math whiz. You don't have to be a math whiz and go through all these equations and trying to figure out equations and stuff here like the actual physicists do. This is just to give you an understanding of quantum physics. Alright, so what I wanted to do was start with here. And I'll edit this video just a little to cut out some of the more boring parts here. But anyway, I wanted to give you a few things here. Alright, so classical physics, we are concerned with the nature and behavior of big things like the planets, the stars, planes, trains, automobiles. That's the physics of Isaac Newton. The physics of the visible and tangible world around us. So that's the actual classical physics. So the quantum physics, the world where particles can pop up in and out of existence. Particles can exist in multiple states at once. So this is studying all the little bitty things, the little small things. Alright, so the goal is to define and describe the proper basics. Let me start over there. The goal is to define and describe the properties and behaviors of nature's basic building blocks. Alright, so I'm going to I have a few places marked here. I'm going to go to the next one. Okay, so this quantum physics goes back a long time. So this is talking about 1690. Alright, so by the age of enlightenment in the 17th century, several renowned European scientists started to think differently about light In 1690, Christian Huygens, a Dutch mathematician and astronomer, proposed an equation describing light as a wave in his treatise on light. So all these physicists, they would actually like write out a paper and submit it to the scientists into journals to get their work published. So he was saying that the universe is filled with an invisible material called ether, and that light is formed when a luminous body in the ether creates a sequence of waves or vibrations. So these waves go onward until they come in contact with our eyes to produce vision. Even though his equation was flawed, it marked an important step in our understanding. So that was Christian Huygens in 1690. So that's how old quantum physics has been around. It started way back then. Alright, so here's another example too. In 1801, Thomas Young published his paper on the theory of light and color to the Royal Society. So with a single experiment involving only a piece of metal and a couple slits, he bravely refuted 100 years of Newtonian beliefs about the true nature of light. So that was 1801. Thomas Young, he was doing experiments with light. Alright, so he cut little slits in the metal, and then when he shined the light through it, that's the kind of experiments he was doing to show that it was a wave, that light was actually a wave. Okay, so here's the next one I wanted to read. Light is an electromagnetic field in 1845. So this was in 1845, while studying electric and magnetic fields and how they affect each other. So Michael Faraday noticed he could induce an electric current by moving a magnet near a wire. The faster he moved the magnet, the greater the voltage produced. He described these electric and magnetic fields and the connections between them in detail, and hypothesized that light itself was nothing more than a combination of electric and magnetic fields. So this right here is actually describing how a generator works. So like here in Florida, a lot of us have generators here because we have the hurricanes come through. So sometimes we have like electrical storms, so sometimes they'll put your power out for a couple hours, and you can have a generator to give you power. And then we have the hurricanes come through sometimes, and they'll put our power out for a couple of weeks at a time sometimes. So a lot of people have generators. Plus we have them at work too. We have generators at work for when we get new houses. When we get to a new house that don't have any electricity, if they don't have power run out to a power pole, then we can take a generator out to the house and be able to work, putting cabinets in. Plus you have like all the RVs, the motorhomes, they all have generators in them. So you don't have to actually have the motorhome running. You can get to where you're going. You can shut down. You can crank up your generator and run your air conditioning and refrigerators and stuff like that. So this is actually starting to talk about how generators were created here. As far as that, it's not actually saying that in here, but that's how the generators work. And that was Michael Faraday. So that was in 1845, and Faraday is really famous too. If you've heard of the Faraday cage, he's really famous. So I'm just kind of going through here and highlighting a few things here about the quantum physics and getting you introduced into it a little bit here, and letting you know you don't have to like be a math whiz and do all the equations and stuff. Alright, so here's one part that I've been teaching a lot too here over the last year or so, and Ron Morehead talks about it too in his book. He talks about it at the conferences that he goes to and on his when he's doing podcasts and stuff. So I have playlists on my YouTube channel. I have playlists of Ron Morehead. You can go on there and there's a bunch of different videos on there where he was on podcasts. I have a playlist on quantum physics. You can go on there and watch a bunch of different videos that explains a lot of different things about quantum physics and quantum entanglement. And I also have a playlist called Skinwalker Swamp, which is showing a lot of the videos, some of the videos that Chris Connor did at the Trail to Bigfoot, where he's about a year or so back, a couple years ago, started out calling Green Swamp the Skinwalker Swamp, and then continuing on into some of the stuff I'm doing with him out there in some of our videos now. So all of our videos that we're doing now from our recent trip out there to the Green Swamp, you'll see that on here too, on that playlist, Skinwalker Swamp, on my playlist. Alright, so I wanted to get into this too about the about light, because a lot of our tools that we're using now, the technology actually came from quantum physics and came around because of quantum physics. Like the lasers, I use a laser level at work, putting cabinets in, installing cabinets, and that came about. The laser came about because of quantum physics. So we have tape measures now that'll has the laser on it that'll give you measurements. I've seen a granite countertop guy come in to template for countertops, and he set up a laser level and it gave him measurements. It measured the whole all of the cabinet area for the countertops. It gave him all the measurements he needed for that. We have the new cars now that drive by themselves. That has the LiDAR system in it that came about because of quantum physics. So you're hearing stuff about LiDAR. Some of the TV shows, Expedition Bigfoot and the Skinwalker Ranch. You're hearing a lot of stuff about LiDAR and them using the LiDAR stuff on there. So that all came about because of quantum physics. So we have a lot of stuff like that. The X-ray machines that they use at the doctor's offices when you go get an X-ray for something, that came about because of quantum physics. So the quantum physics, we only see a small percentage of light, which is called the rainbow colors. That's the different colors that we see. So there's a lot more. There's X-rays, there's gamma rays, there's UV rays. There's a couple animals that they think can see UV rays. I think the deer might be. I think the deer are one of them. If I remember right, it said deer can see UV rays. The infrared. The infrared came about because of this too, or that's part of the infrared is part of the light spectrum. But we also have infrared cameras, thermal cameras, because of quantum physics, that came about because of quantum physics. So that's another thing here too with like talking about hurricanes. We get the hurricanes come here, or forming out in the Gulf of Mexico or the Atlantic Ocean. We have the on the weather, you can watch the Weather Channel and they'll show you the infrared camera, the storms. They'll show you what the storms are doing and where they're moving. That came about because of quantum physics. So we have another part of light is microwaves. Microwaves is or electrical currents. It's a part of light. So light is like if you turn your microwave on and you're standing close to your microwave, you're getting hit with microwave currents, which is a radio frequency, part of radio frequency, and radio waves. So on our radios that we listen to, AM stations and FM stations, is part of radio waves, part of light. That's another part of light. So that's all this has been discovered because of quantum physics. And then you have long radio waves. So I'll put this. I'll take a picture of this, and I was showing this at the Bigfoot conference. So I'll put a picture of that on there too. But that's what I'm looking at here to read all this out to you. So I'll put a picture of that up on here too, so you can see what I'm talking about here. All the different sections of light here that we cannot see, and then the one little section with just the colors of the rainbow, like the colors that we can see. The red, yellow, green, blue. Another thing too I'm learning too is that like when we think our brain is actually, our thoughts are going out as light waves. So that's another part of quantum physics too that they're discovering and talking about, is the when we think, our thoughts are coming out as light and going out into the universe. So that's another thing there too. So there's a lot of things that you learn about when you're studying physics, quantum physics. So that just made me think too, there's actually a section in here too where they talk about the atomic bomb. So the atomic bomb was actually invented because of quantum physics as well. Also, this book goes into talking about nuclear reactors and radioactivity and stuff like that. So here's one of the parts where they're talking about the light experiment with the slits in the metal and shining the light through to determine if light is a wave. And then you can see that they show all the different equations here. All throughout the book, they show the equations that the different quantum physicists came up with, like Einstein, like his equation there. That's the real famous one there. So there's a part 2 here where it talks about the Earth, and it talks about space-time. It talks about how space-time has been around the Earth, and that causes gravity. So there's a lot of good information in books like this. So there's 1915. They're talking about Einstein in 1915 and his theory of general relativity. They talk about Newton. They talk about Planck. They talk about Bohr. There's a lot of different scientists in here that they talk about. See, here's another part I can read too. This is talking about says strange facts. They give you a lot of strange facts in here too as well. So time dilation occurs all around us at all times, near all objects with mass, even on extremely minor scales that are difficult to measure. For example, you would experience time more slowly at sea level than you would if you stood at the top of a very high skyscraper. Similarly, if you were orbiting Earth, time would progress faster than if you were on the surface, which explains why clocks on GPS satellites orbiting Earth regularly fall out of sync with clocks on the Earth's surface and must regularly be readjusted. Note that large masses and high speeds can alter the rate of time's passage, but that it always moves forward. At the time of this publication, backward time travel remains theoretically impossible. And he says sincere apologies to science fiction fans everywhere, because he stated that. So he's saying at the moment that at least that we know of, that we cannot go back in time. Backward time travel remains theoretically impossible. There's stuff in here about wormholes. So this some of the things that we're actually trying to study now too ourselves and find portals, wormholes, rifts, things like that. So that's another reason too I wanted to talk to you about some of this and read a little bit out of the books here. Where this is talking about wormholes. It talks about gravity. It talks about dark matter. It also it tells you about Schrodinger's cat. That's a really big thing too with quantum physics. If you hear about Schrodinger's cat, it goes through in detail and tells you all about that. So Schrodinger actually started that out as a joke, and then what he actually discovered with it is really famous now. Alright, so there's a part here too where in 1927, so Paul Dirac in 1927 he put out a paper, The Quantum Theory of the Emission and Absorption of Radiation. So he's talking about radiation here, electromagnetic radiation. Chloe, stop. See if I can say that right. Electromagnetic radiation. There we go. And that was Paul Dirac. It talks about him. He won the Nobel Prize in 1933. And this was talking about his paper in 1927. So there's a lot of really good information in here. And you really learn a lot by studying some of these things. Alright, so here's another one. Let me read this. This is another one I had marked I wanted to read. This is another strange fact that they put in here. The race for the world's first laser began in 1958 when two scientists published a paper describing a way to bring Einstein's laser ideas to life with potassium and infrared light. Several top-tier scientist teams around the world, including the Soviet Union, received millions in funding to produce the world's first laser. So that was in 1958. So a young engineering genius named Theodore Maxman, armed with only one part-time assistant and 8 months behind the competition, he won the race in 1959 with a tiny ruby laser. He did it with a budget of only $50,000. And that would have been really a lot of money back then compared to now. But that was in 1958. So in 1959, he come up with a small laser, a ruby laser, tiny ruby laser. Alright, so that was Theodore Maiman. Theodore Maiman. I'm trying to say it right. Alright, and this gets into cars that drive themselves. So the self-driving cars using LiDAR, using the LiDAR to detect the surroundings. So we have a lot of technology now because of the quantum physics. The lasers, the LiDAR. We have, like I said, the X-rays, the X-ray machines. There was a part in here that talked about a woman doctor that was trying to get funding to get back in World War II, trying to get funding to get an X-ray machine, a vehicle, trying to get a vehicle with an X-ray machine so she could go around and help the wounded veterans, the wounded soldiers, and actually ended up saving a lot of lives because of that, because she had the X-ray machine in a mobile vehicle, to be able to get around and then help save a lot of lives because of that. Also, we were doing a lot of stuff too with GPS locations out there in the Green Swamp, and where it was shown we were so most of Florida is about like 90 to 100 foot above sea level. So we were getting that in places, and then the GPS would jump. At one spot we were 197 feet above sea level, and then another spot we were 300 feet above sea level. And it's all flat out there. You can see by my drone footage, when my drone goes up too, it's just all flat. You can see the tops of the trees out there in the horizon. It's all flat. So the GPS was actually showing that. And then at one point it showed we were 80 feet underground. So that's some of the strange things we were getting out there in the Green Swamp. And that's some of the things that we were testing too out there. And the GPS and the GPS satellites, all that has now come about because of quantum physics. So some of the tools we're using. So if you keep a watch now, so this talks about atomic clocks. Alright, so there's a lot here. Alright, so this gives you a lot of really good information here, these books like this. I'll share the link to this as well, and it helps explain a lot of things. Alright, so there's some little bit of reading through the book here to hopefully bring a little bit of quantum physics to you and help explain a little bit about what we're doing and what we're trying to accomplish here. So I use my thermal camera a lot out there in the woods, and I'll sit down and I go through it really slow, frame by frame, basically frame by frame, and I'll see a lot of stuff. I'll go through and I'll watch for movement. I go through and I've compared birds, bugs, all kinds of things in there on my thermal footage, and every once in a while I'll circle something and point it out to you, or put an arrow pointing towards it. So that's one of my favorite tools, is the thermal camera, which came about because of quantum physics and the infrared. Alright, so there's that, and then just keep a watch for our videos on the Skinwalker Swamp, things like that we're doing. I'll put the links into these books for Amazon. I'll put the links into these books in there for you in the description if you want to go check them out and read them. And like I said, I got playlists on there, quantum physics playlists, the Skinwalker Swamp playlist. So everybody that puts out any of the videos that were on our team there, I'll add them in too as well. So I've already got some with Chris Connors, the Trail to Bigfoot, some of mine, and the podcast we did, stuff like that. Chloe, stop. Alright, so there's that, and thank you for watching, and hope you get a better understanding of quantum physics here. So check this out, speaking of LiDAR and self-driving cars, the self-driving car was driving in the wrong lane, so a cop pulled it over. So they ticketed the company that had the self-driving car, since there was no driver to ticket. It was driving down the wrong lane. It's a self-driving car.